Today, I've got a subject, microservices in the monolith world. It's a subject that perhaps not the sexiest thing these days. Microservices have been talked to death. But what I've got is a story, because not everybody's yet used microservices. Some of us are in the transition. Some of us have actually got to use microservices in anger. But most of us, I think, are actually in that transition phase. So how can we transition is kind of what I'm going to be trying to address here. So let me introduce myself properly. I am a Oracle ace. I started out as a developer with open source. So I do know what the world outside of Oracle looks like. And I have to say, the last couple of years, I am rather impressed with the way Oracle is engaged with the open source community. And these events, I think, are just another aspect of that. I have written a couple of books. In fact, our latest book, this one, is going live today. I'm told it will be uploaded and you can order it and buy it and download it and laugh at it from today onwards. All the source code that we've used in the book's available online. And what we tried to do in there is talk about not just about the Oracle product, but how to do microservices as well, and the relationship between APIs and microservices and so on, and some of the design techniques that you might consider that will help with APIs. But we're not here to talk about that. That was my first attempt at a book. And I don't know if Robert's here or not. I'm guessing not, I can't see him. But that was our first book on the Oracle Integration Cloud, which is a great product. And then the team at Capgemini, of which I am part, have written numerous other books and articles and things like that. And yes, we've won a few awards. So let's just look at what we're going to talk about today. So I'm going to try and attack the question, what is a microservice? Yeah, I think it's important, before we can talk about a microservice and how to do it, and how it might look in a monolithic world, what is it? Then the question is, obviously, if we know what a microservice is, how on earth can we make a monolithic container? Now, today's an Oracle event, so we're going to talk about WebLogic predominantly, but a lot of these ideas will actually stand up using WebSphere or Wildfly or JBoss AS, as it used to be called. Equally true. Once we've sort of understood what that looks like, we're going to explore a little bit around the development and what that could look like and how we can make that work to get that journey moving. And we'll talk about some of the strategies to help that transition. So it's not a case of, I want to do microservices now, but I can't have Kubernetes and Docker and Istio and everything else. You'll be on a path that means that when the powers that be say, yes, you can move away from WebLogic and use something that we typically associate with microservices, it's a seamless, fairly painless transition. It's not rip up the rule book and start again. Hopefully you'll have a couple of takeaways and we'll talk about that. And then we should have a little bit of time, unless everybody wants to run off for coffee because they've heard enough today, to have a little bit of a Q&A if you want, or debate if you don't agree with what I'm suggesting. I mean, these are my views. This is based on my experiences and the work and research that I've had to do to master this sort of technology and help guys and help customers transition. So what do we mean? So I'm going to actually start by asking you to throw out some words, terms, that you would associate with microservices, or a description if you care. Anybody willing? Yep. Scalable. Anybody else? Yep. Any more? Bounded context, yep. Small components. Eventual consistency, all good words. You've all been reading the books, and I'm knackered. One of the things that we tend to do when we talk about microservices is get hooked up on the technologies. And I did that straight away. I started talking about Docker on Kubernetes and Istio. Yeah, and you'll see Prometheus being talked about, Kafka, Nginx, and the list goes on. Now, that's all well and fine, but actually, I think, and I think you've just confirmed it, microservices are about concepts, design concepts, ideas, goals. You know, you've mentioned the bounded context, small components, scaling, or elasticity, as you can see, I've got it in there. So it's all about these ideas and how do we get there. So actually, I'd say to you, you might be working on WebLogic. Yeah, you might be working with WebSphere. That doesn't mean you can't do microservices here now today, because it's about those ideas and how they're realized. Now, Docker and Kubernetes and those sorts of technologies make it easy or easier to achieve some of those, but it doesn't mean you can't do it now. So just to reaffirm, I went and looked to see what the experts say. So you've got Sam Newman from ThoughtWorks. He wrote one of the best books out there about implementing microservices from O'Reilly. You got God himself, Adrian Cockcroft, who started out at Netflix, the poster child for microservices and APIs. Yeah. And Chris Richardson, really good resource there, not so well known as perhaps the other two guys, Microservices.io, where he's got a patterns catalog being built out. And you see, particularly in the first two, there's absolutely no technology reference at all, in any shape or form, which just underlines the fact that this is a concept, not a technology-based issue. And even in Chris's description, he uses the technologies as illustrative, not as mandatory. And in fact, yeah, we talk a lot about Kafka. He actually makes reference to AMQP here for the event-based framework. No Kafka at all there. So let's just look at and compare some of the diagrams. So these are based on diagrams that were produced by Martin Fowler originally, and I've tinkered with them. So this one that you'll be familiar with, this is our traditional development model, our big WebLogic container environment. Okay, and you probably can't see at the back, but just down here, there's a solid bar that binds all of those components together. So if we want to scale it, we have to scale everything. Yeah, and scaling up is quite difficult because you have to change all the configurations for cache sizes and things like that for each component within the container. You can scale out quite easily. You know, WebLogics can run in clusters without any problem at all. You can even run them without clustering if you want. So that's what we're familiar with. You go to the other extreme. This is the ideal that's being presented as microservices. Everything is discrete. There is no connectivity between any of those components at all, as you've mentioned. And actually, they show, as you can see, the service is pulled together to form the UI as one piece. But there's a middle ground. And this is kind of where I think a lot of people's journeys are best suited. Gartner talked about this as micro apps or mini apps. They started talking about it, I think, about 18 months ago. Doesn't come up too often in their text, but it does occur. And what they're saying, and this is what I would advocate, is that you're using a monolithic container, but you're starting to break pieces out. Those easy pieces that are easy to pull out because they're fairly loosely coupled anyway. Pull those out, run them as discrete elements. Yeah, the bigger pieces, leave as bigger pieces. If they're difficult to split up, don't fight your code in one hit. All right, start with the easy stuff, break it out, prove the processes, prove your development techniques that you're going to have to realize with this. And this is what I call microservices in a monolith world, because you're still likely to be, in most cases, using a larger WebLogic style container rather than Tomcat or Jetty or Nginx is a container. So I've talked about what it is and what it could look like. Why do it? Now, it's nice to talk about microservices. It's nice to be able to do the funky latest stuff. And we will, and I'll put my hand up with this, mugs for shiny new gadgets and new ideas and toys. And it's lovely to get your hands on and go, oh, do you know that Project FN? I hacked out some fantastic code last night. It was brilliant. Yep, it's absolutely is. It's great fun using this technology, improving new ideas and trying things out that you've never done before. After all, coding that algorithm to calculate tax again is pretty dull as a day job. So we do it for cool. But is it the right reason to do microservices? The problem with doing them for just the sake of it's the cool, it's the shiny, it will keep the developers happy, yeah, and I include myself in that, is are we missing the point? Martin Fowler and about half a dozen other separate individuals I've read have said, actually the best way to journey to microservices, the most successful way to microservices, is actually to build the monolith first. And they say that because the idea is that in the process of doing the building, you're discovering your full scope. How many times have you written a bit of functionality and someone comes along, oh, but I wanted this as well, and I wanted that, and you keep plugging little bits in because they didn't give you the full scope to start with. So what they're saying is build it up and then break it down. You'll find the natural fault lines within the code where it's loosely coupled, where there may be one or two boundary calls. I mean, this comes back to the idea of the bounded context to an extent. So what they're saying is build your monolith first, then decompose. Okay? The other thing here is microservices are much about organization and people and processes as it is about technology and concepts and architecture. If your organization can't cope with the idea of small, discrete, functional development teams, we've long heard about the two-pizza team, yeah, but how many organizations really run their development activities purely two-pizza and separate teams out? I mean, I have to, in my travels, haven't seen too much of that. You've seen the teams intermingling quite a bit. But what they're saying is, you know, if I draw the classic triangle, people, resources, time, yeah, process, people, technology, you've got to be able to move all three parts to affect proper change, real change. Otherwise, you're just moving the problem around. All right. So, if we don't do microservices with a view and an eye on the real value propositions of microservices, there's a chance that we can end up building a worse monolith, a distributed, tightly bound solution, where if you then get asked to redeploy it clean in a new environment, it becomes a hair-pulling, frustrating exercise because you can't work through the dependencies anymore because you've just been adding and adding and adding. So, whilst it's nice and it's sexy, we need to be mindful of the reasons for doing it. And if we know what we're doing it for, we can measure whether we're being successful or not at hitting the goals. And therefore, are we doing microservices properly? So why do we do microservices? Well, we're looking to answer questions like, I need to be able to scale my solution in very different ways. Yeah. Let's say I'm an Amazon competitor. Not that I've got much luck or chance of competing. Black Friday, if I'm using some sort of caching technology, most of my product pages are going to not increase in terms of the amount of demand my environment receives, but my payment processes will, because they can't cache. So I need to just scale up just my payment piece of my service, of my solution. So I need to flex and change the shape of how I deploy and scale. I need to drive out reuse and improve reuse. We've done SOA for a long time, and whilst SOA talks to this aspiration as well, SOA tends to grind because of its granularity. Most SOA situations I've seen trying to focus too small a component. And just to illustrate that, you look at products like Oracle Enterprise Repository. It's looking at components at the size of a Beeple process or an XSLT transform. That's what it harvests up and catalogs. Way too small. But I need to still have modularity. I still need to be able to separate out my payment processing from my invoicing and billing. I mentioned the scaling. Of course, elasticity is another one of those poster child things. But need to be able to future-proof my offering. Doing microservices, you can rebuild and build new versions and phase components in and out far more easily than if you can in a monolith. So let's tackle some questions and some perception issues. We tend to think, and I've said it myself even in the last 5 minutes, microservices are easy. Well, to an extent. We all recognise that structure, done it to death. You know, an app running on top of an app server of some sort. If you're very old school, you'll be using toys like Corba perhaps, or even going back beyond then. Running on a host server, that could be a VM or it could be bare metal. Okay, now in a normal small solution, that is quite easy to understand. And you can get your head around the whole app, understand all the things that you use in the app server, and even perhaps know a bit about what the host server is doing. Compare that to a microservice. Okay, so far so good, the same, so what? Then we're into container management. We need to manage each of those little microservices now. So we've got a new technology to deal with here. And then we have our containers. Oh, and now we have an app server. So where I had 3 pieces on my left, I've got 4 different technologies already on my right before I bring my application into play. So are microservices easier? You could argue, and I would say to you actually in the small, when you're dealing with smaller solutions, microservices actually demand more from you. If you're in a small team delivering that full stack, and we do talk about full stack developers, you not only got to now know how your app server works, how your application works, you also now have to understand how Kubernetes works and Docker, and make it work well. So, in the small, you would need to know that. In the small to medium, in the microservice-based technologies, you're looking at knowing a bit of everything. It's only when you start getting to scale that your problem in your domain and the amount you have to know to be able to action change actually decreases, and you start to get that real value. Yeah, if I've got a big solution, I can afford to dedicate teams now to the app server and my Docker container. Because setting up your app server and your Docker container, you're going to encourage people to build as few configurations as possible. You're going to have maybe 1, 2 people looking after your Kubernetes environment. Yeah, and then leaves you, or leaves us, the developers, hopefully to worry about the application. And because we've now partitioned it, we can think about just a piece of it. Trying to get your head around all of this on a very big application is a nightmare. That's why we get the code sprawl, why it gets messy and a problem, because you just can't get your head around everything. You know, somebody's written code in this big app 2 years ago, they've cleared off, left the company, and you're left with, do I maintain this? How do I modify this? So actually, do you know what? I've got to deliver this tomorrow. I'll code round it. Classic challenge. I was going to say mistake, but actually it probably isn't a mistake. If you're under pressure, you've not got much choice. You have to work around these problems. And that's why we get into these headaches. Keep the scope smaller, keep dedication onto one component. And as things change, you'll be able to maintain it and change it with the evolution. And this brings back one of the other arguments that you'll hear if you start looking at the architectural strategies around microservices. You'll hear that people saying, you've got to think like a product. So you build it and you stick with it. Yeah, you have dedicated teams working in one area. They don't write it, then move off, and that's it. You need to start to think more like a product, and what's the next release, and what's the next release of that component, and therefore keep momentum and knowledge in that component and how it works. Now, I've given you the two extremes again. So here's my macro app. As you can see, I've now partitioned my app, but it still sits on a single monolithic app server, which still sits on top of my big server. But I've reduced some of the challenges that I have by doing that partitioning. I can do some of the microservice contraction that you can see. Still need to know my app server, but only the parts that I use. And I need to know my app, but my app isn't too large now. And of course, you might need to know a little bit about the hosting environment. And you can take that another step further. Yeah, you can take in WebLogic and others. You can do separate the solution up, and I'll show you in a minute what it could look like, so that the runtime isn't so monolithic, a single service, single process in the OS, but multiple processes, discrete processes, with its own threads, its own memory allocation, giving you the idea of what microservices refers to as bulkheads. So if anything goes pop, it doesn't take everything out, only takes out that piece. So going back to what Martin Fowler was saying, just to underline that there is an overhead until you get up to size when dealing with microservices. He drew this graph. And what he's saying here is that in the early days, if you start with microservices and you go on a clean sheet, you actually got an overhead. Yeah, you've got that Docker and that Kubernetes or an Istio and the orchestration pieces to deal with. And that's what he's trying to describe here. But when you get to the momentum and volume in your environment and the solution becomes quite substantial, you move into this end here, where the relationship's effectively inverse, because to try and keep a huge, big application going in a monolithic model gives you difficulties because of the size and the complexity and the amount you need to know to be able to do one little change. Whereas with a microservice, if you've got dedicated teams to the services, actually they'll know and understand the entire scope of their service and go, aha, to do that little bit of functional change that you require is 2 lines of code change there. Quick change, build, deploy, bang, done. And what I've done is overlaid this middle ground, which, as you can see, sits in the middle. So you pay a little bit more in terms of initial effort because you've got to set up those separation layers that I've described. But it's not as challenging as, say, learning new technology and writing a Docker file. Yeah, you probably, if you've worked with one of these app containers for a while, you'll probably know most of the way around how to configure up the separation, which I'll show you in a moment. But the benefit does tail off, as you can see. Now, I haven't done mathematical research. I haven't proven this in every case. This is perception based on what I've seen so far and how the benefits have drifted off. And it does look like it tends to trend down. Okay, so I've sold, hopefully, the idea of trying to do microservices or micro apps using a larger container server. Yeah. So why would we want to try and do it in WLS? Right. Classic arguments. And the first one is the one that I've encountered a couple of times. The company's invested an awful lot of money in the licenses for WebLogic server. They've invested in the support for it. And the amounts of money involved in that expenditure means that people are not willing to move away and abandon it and say, hey, brand new world, forget that. Yeah, you can throw all my licenses away. We'll start with some new technologies. It's just too embarrassing to admit you've just spent 2 years ago, say, a couple million quid on licenses and support, and now you're not going to use it. Some companies, and I include one of my previous employers in this, have a strong vendor view where they don't like lots and lots of different vendors, which kind of goes against some of the microservice ideals of polyglot, where you start to bring lots of little things, build it the best way for that particular problem. Yeah, so I might use Kafka because I need to do event streaming, and I might use Nginx in one place, and I have another team that specialises in, say, Go in another, and therefore my company policy is I have to have all these technologies supported so that if there is an operational issue, I have someone to fall back to help me out. So what you end up seeing is companies going, we'll have Oracle, and we'll have Oracle everything, Oracle database, Oracle middleware, Oracle apps, and our support agreement is just with Oracle. Makes my commercial position really easy. I have one person to go and beat up if I need support. Not necessarily ideal, but from a pragmatic perspective, you can see why people do it. You see this open source, closed source argument, and it tends to be a proxy about who's providing the support. Yeah, you say it's open source to senior management, and the reaction can be, who's going to support me? When the code goes wrong in Nginx or Docker, who's going to support that? Who's going to give me a quick fix and get me on moving? Who can I beat up if I can't get it fixed? Because you've just taken the source from the internet. So, and are we going to depend on one individual to be an absolute expert in how these technologies work? Not necessarily the best position. Right, now partners, and even Oracle now, are offering certain services to support open source. So hopefully we'll see that argument disappearing. Which comes to the second point, which is a lot of vendors, and I'll take Red Hat as a really good example here. They'll take an open source solution and they'll harden it and they'll test it to kingdom come and say, right, we guarantee this will work for you. And if there's a bug, they'll come in and fix it. And then there's the vertical alignment debate about, well, if I'm using Oracle's ERP, I ought to use their middleware because it's going to be naturally fitting. We all know in practical terms, Oracle's SaaS solutions don't necessarily work beautifully in tandem with Oracle PaaS and so on. So let me show you now what it might look like. We have a server. And we have a traditional view, which gives us an admin server and a single domain. So we have a managed server in there, and we'll have within there our standard services, JMS, JNDI, and the list goes on. And then, of course, you've got the node manager, if used properly, we're there to keep things up and running nicely. Okay. No shocks there. If you used SOA Suite in the past, it kind of looks like that. And then you get a pile of your own jars or SAR files for SOA, which you just end up piling into the domain. That's the start of the challenges. Yeah, there's your config files. No separation there, so you create a config and I start using it. You don't know about the fact I'm using your config and your JNDI tree to get a connection to the database. Now, we could go to solve this problem down the route of, Oracle have given me WebLogic as a Docker container. Great, fantastic, problem solved. Or is it? It's a bit big for a Docker container. Right, but what it allows us to do is perhaps not use it as a dedicated microservice container, but we could use it to accelerate our CI/CD processes, our continuous integration. Because one of the things that you see in good continuous integration is the ability to blow away the environment, start fresh on every test cycle. That ensures that there are no implicit dependencies is building up. You know, it's a classic mistake I've seen in a couple of setups where Maven's building and it's putting dependencies into a file location but never clearing them down, and then somebody later on has actually built some code. It works in the build environment because actually they were dependent on a library that was dropped into that environment from 10 builds ago but no longer being declared as a dependency. So when they deploy to their nice clean production environment, oh crap, it doesn't work. Yeah. So using it Dockerized WebLogic is a great way of being able to start from fresh every time, and you haven't got to go through the pain of setting it up because it doesn't. It takes a little bit of time to set up WebLogic. Okay. So now let's move on and look at the WebLogic in the micro app. So I have my admin server again, my managed server, my standard services. Now here's one of the things that makes it a little bit different. I've put a partition in now. In a partition, you can dedicate resources. Yeah, and you can actually, if you've got the right license for WebLogic, I can have more partitions, as you'll see in a moment, but anything in that partition, it can use the shared services, like a JNDI tree, but it also can have its application and all of its configuration kept completely private. It has its resources allocated to it, so it's not shared at all. Now, this kind of gives us a simile to a classic microservice in the container sense of the word. Yeah, because it's hitting all those key themes: isolation, independent control, private configuration. So you've got the loose coupling that without compromising cohesion. And we can actually look at Node Manager as being a bit like certain services in the traditional microservice model. You know, when a node falls over in a full-blooded Kubernetes-style cluster arrangement, Kubernetes will put a new node up for you. Actually, Node Manager's responsibility is to look after your managed container and put it back up on its feet if it falls over. So very crudely, it's actually there doing some of the things that you need it to do, that you do in a full environment. People sometimes start just putting everything in the admin server. That's a no-no, really, because you're not going to get the benefits here. You don't even need an admin server in a WebLogic environment. It's there to give you really an easy way of seeing what's going on. Yeah, a web UI running everything through WLST. All right, let's take this further. So I have my first piece of functionality, my first microservice, using the architectural approach to microservices. Now I have my second one. Separate partition. So the two do not know about each other's existence. They are completely invisible to each other unless you, like a proper microservice, have built communication between the two. Yeah, be that event-based through an event hub or REST API calls. They don't know about each other. And you can now start to think about redeployment. Yeah, I can deploy my partition on a different server if I need to. I can deploy them together and just duplicate them like I would with a monolith. Or I could do a combination of both. It becomes a design decision, a deployment decision based on need, not on limitation. And actually, Oracle talk about this in their own documentation. So it's actually, this is not me, this is actually, when I was digging in, because I realized that I could do this, it was like, oh, hang on, let's see what Oracle says about partitions. And they actually ended up talking about services and decoupling, all those key words. And this diagram down here, on the bottom, is actually from their documents. Now we can scale this all up. Allocate VM capacity to each of the partitions. I can scale out using the different models. Yeah. But importantly and usefully, I'm not duplicating all this functionality. All the core logic gets put into each deployment, but the configuration is in here for it. So the JNDI tree is private to there unless I want to create something that's global. Clustering, WebLogic provides it. Do I want it? It's been an interesting subject and one that I've discussed for God knows how many hours with my colleagues, that particularly the ones that are more knowledgeable about WebLogic, about whether it's the right thing or not to do. My colleague says, well, it's there, use it. Makes deployment an awful lot easier. Deploy to one node and all your components apply to all nodes. Yes, makes life easier that way, but aren't we moving away from some of the ideals of that discreteness, that decoupling, that transparency? Therefore, I would argue that whilst it's nice, it's probably not the best thing to use. So I've talked about the container, but one of the key services that we use a lot is messaging. Now, messaging in microservice land is important because we talk about choreography vs orchestration. Everybody comfortable with the idea of the two? Yeah, so choreography is the idea that each component knows its own job, and once it's told what it's meant to do, it just does it when listening for the beats and the cues. So if a message comes along of a particular type, it will go, oh, right, now it's my turn to do something. And it will do something. Whereas orchestration is the idea that somebody stood outside of all the components doing all the work, is telling who to do what when, you know. If you're from the server world, you'll kind of relate to this, where you've got something trying to tell all the different pieces, moving pieces, what to do when, and it's complete chaos. And the bit outside that's trying to control all of the activities is got steam pouring out of his ears. Right. So the idea is that we use choreography, not orchestration. That means every component needs to listen into events as they happen. That kind of says JMS to me, out of the hat. But JMS has a challenge. It's lovely. JMS, if you look at the specific definition of JMS in the JCP, it actually describes the API contract, not the payload and how it gets carried over the wire. right? You can actually do it any way you like, as long as you meet that contract, the API contract. That doesn't work when you've gone polyglot. Yeah. So what happens when someone comes along and writes a Node app to go into my environment? That means Node has to understand the wire level protocol, how that payload is being transmitted. Now, most of the time we end up just using text, but how does the underlying protocol carry it? So, not so great because of the lack of the wire protocol. That doesn't mean JMS is dead in the water entirely. Doesn't mean we have to give up JMS. It means we just need to think about migrating away from it. And there are a number of ways of solving that one. Kafka, if that's the way you want to go, has a JMS spec interface. So you can carry on using JMS as you decouple and break out your components. You can use your JMS, keep calling the queues as JMS, but the back end, you can start to switch over to using another technology such as Kafka with its JMS adapter. And then when you get to revisit a component, whether you replace it, rewrite it, modify it, you can start to run using the JMS connector. You talk directly to Kafka because that's your design decision. Or you could say, actually, do you know what? I want to be completely solution neutral. I'll keep with JMS because that gives me the opportunity to put in whatever I like behind it. To solve that problem, you don't have to necessarily use Kafka. You can use AMQP. It's an industry standard that matches JMS for topics, doesn't do queues. All right, but there is an adapter, and it treats a queue as a topic. All right, but gives you the wire-level protocol again. So now you can then talk to a Node or a C# component or whatever else is on the consuming end of your queue, or should I say topic. Gives you that portability. And again, because it's using the JMS interface, you can replace the back end without throwing away reams of code. Yes, you need to test it again to make sure you've got your config right and it's performing okay. But it's not a global rewrite, which is where people start to take fright when you talk about microservices. Oh, the other thing to remember is Kafka. It uses HDFS at the bottom. Now, I haven't deployed Kafka, but I have encountered quite a few challenging stories about using HDFS to get it to be really effective. Okay, almost done. So we've got a strategy now for translating our components and breaking them down. We have got some ideas on how we can start doing that decoupling without breaking everything and starting from scratch. What about all those other design ideas? Well, if you're working on new stuff, the idea of bounded context was mentioned earlier. The idea of bounded context is that rather than having one monolithic, great big data model and trying to work to it, and that in itself brings other possible challenges. Chris Richardson talks about them as God classes, where everything comes down to an object like order or sale, and it pervades the entire application, which means that trying to change that order object can have quite frightening consequences because you don't know how much code you're going to impact. Or you do know what it's going to impact, and you wince at the amount of recompilation and testing. So what the idea is that you take your model from a high-level view and you break it up. And now, in each area, I have, rather than sharing an order or sale object, I have my own representation of it in that context. Yes, you have to write a bit of code, so when you cross those boundaries, you're mapping them across to the different representations. But you're probably doing that anyway, because you're doing that decoupled invocation. And what I've done here, so this is an illustration of a sort of bounded context, high-level view. This is actually from the book, where we explain the idea of bounded context and how it relates to the APIs. And you just look at it. Once you've got your high-level objects, you can start to put the relationships, and you look for the nice fault lines where there's the lowest level of coupling to find your boundaries. It can look a little bit scary, but it does work. The other thing is obviously good old-fashioned patterns. So I mentioned Chris Richardson earlier on. The microservices.io website, like many good patterns resources, gives you all the information. It explains what the pattern's for, or when you want to use it, what the alternates are, and so on. I went and looked at it and said, okay, so how many of these patterns will work in my micro app or my microservice on a monolith? And I found 2 out of, I think it was 20 or so, that just don't make sense. And another 4 that would require some extra components that don't have. So the 2 that don't work, well, one was called Microservice Chassis, and the other one was sagas, which is a strategy that that Chris describes in his book as a way of trying to manage transactions across many components. And even then, that was a bit, well, you probably could, but there's a lot of fresh development style thinking. Everything else you can use now. Yeah, the other 2 that would require extra capabilities, you don't get an API gateway out of the box with most app servers. You'd need to go and acquire something to fill that role. And the last bit, which are these here, is around discoverability. Now, you could argue that one, because UDDI, which you get with a classic container SOA-based environment, is about discoverability. But that's talking about registries such as Zookeeper and etcd and things like that, which you could use and would probably be sensible to roadmap in. Right, moving along quicker now. So, development process. A lot of people I've come across will quite happily pay lip service to continuous integration, continuous delivery, and particularly the testing side of it. It's so easy to get sucked into, I'll write my code, I'll test it myself, and that's it. Rather than putting all the unit tests in and run it in a proper continuous delivery pipeline. You're going to do this, you really desperately need to do that properly. You're going to have lots of different moving parts. Each service is now discrete, can change in its own rate, deployed at different tempos, so you're never going to be sure all the different components that work together until you get to deploy. So it means that testing and testing well is absolutely critical. And actually, doing it and driving all those tests locally will help you make sure you're decoupling and making that isolation robust. But it's a standard process. Spring Boot. So one of the strategies that we've done and had an awful lot of success is we use Spring Boot. All Spring Boot is doing is basically leveraging Spring, right? And all of its different libraries and services. And quite often the Spring components are abstractions onto underlying implementations. So you can actually use Spring and map it onto an Oracle JMS or a WebSphere or another product. So by using Spring Boot, I can now run and build my little applications locally. I don't need to install WebLogic on my laptop to build my code. I don't need it even in my test environment. But then when you come to put it into your Monolith container, you can reconfigure Spring or Spring Boot configuration files to tell Spring you're now running not in a Spring Boot container, which I think is a Tomcat. You can now tell it it's going to be running in a completely different container. Now, it's not for the newbie to do this, I would warn. But what it means is you can pick up and shift this around. It means you can do all your development and testing and run large chunks of functionality locally without the headaches of, I need a WebLogic container on my machine. That takes ages to set up. Don't even need to bother with it in a Docker container. Which all comes back to, if I can do it simple and build my functionality in my code, still using JMS, still using JNDI, I can build it small, and therefore you can create the rule of thumb that says, to be a microservice, it must be buildable, testable, and that service must be able to run on my laptop, my development machine. Not at scale, but it should be able to do the basics. And that's a simple, test of granularity. It talks to the debate of how big or how small is a microservice. And then, just to really confuse things, you can use cloud. Yeah. Don't need cloud to do microservices. I know a lot of people start to say this in text and tie the two together, but you don't. But there's plenty of cloud, and the benefit of cloud is that ability to go back to a clean state again, blow things away, verify that your testing's proving everything every time. So I hope you're going to take these couple of points away, because I think these are probably the most important ones. Microservices don't come for free, and they're not necessarily easy, but they do pay dividends when you get up to scale. You can set yourself on a journey to transition to a pure microservice, traditional, dare I say, if that's the right word, model for using the technology. Yeah, by replacing my JMS, by using partitions, and if you haven't got the partitions licensed, I mean, in one use case we've got, I actually tell the developers there's partitions, but actually they get deployed in the same partition. But it makes them think that loose coupling. Right, and of course, where we started, it's about ideas, not technology. James advertised this morning, if you were at the keynote. I happen to be one of the organisers, and I'm not an Oracle person. I work for Capgemini, so this is quite, whilst it's run at an Oracle office, Oracle buy the beer and pizza, and it is there, and we have the beer and pizza before we do anything, so we get our priorities right. And they're kind enough to give us the use of their office. All right. We have different people coming in talking about different things. A lot of it's more contemporary stuff, APIs, microservices, and it is a lot more free-flowing than this sort of arrangement where we're on time-based. We'll have a couple of subjects that will be presented on, but if the first subject gets lots of time because people want to talk about it, then we change the agenda. Oh, and you'll have noticed I had a little animation going across. We have a running project with the meetup called Drones with APIs. What we've got is we've managed to get Oracle to buy us a drone, and we've built a set of APIs on top of the management code of the API, so we can now control the drone through APIs. So the challenge is for people, when we run a drone session, come along, hack some code in whatever technology you want. If you want to try some Oracle code out, functionality out, like FN or some cloud, ACCS, then be my guest, and we'll fly the drone into things and try to kill a few people. Okay, thank you.